So hello. Today we'll be doing like dynamic programming, like how form one of dynamic programming. So let's start it. Like dynamic programming, it is nothing but glorified recursion with caching. All of things like Fibonacci, NCR, they can be done with dynamic programming. Like Fibonacci is fib of n is fib of n plus n minus 1 plus f of n minus 2. And NCR is equals to n minus 1 CR plus n minus 1 CR minus 1. All what all things can you see here? Right, okay. There is an optimal substructure. What is an optimal substructure? Here if n like n minus 1, like here if n decreases to 0, our answer will be 1. And if r decreases to 0, our answer will be 1. This is an optimal substructure of the problem. What is optimal substructure in Fibonacci? In Fibonacci, optimal substructure is Fibonacci of 1, which is 1, and Fibonacci of 0, which is 0. Right? So it is an optimal substructure. We can apply DP on problems only which has optimal substructure. And what all it can have, and it should also have overlapping problems of it. Like what is overlapping problems? In calculating Fibonacci of 10, you have to calculate Fibonacci of 5. And also in calculating Fibonacci of 9, you will have to calculate Fibonacci of 9. So why not, uh, when you take the value of 5, like when you get the value of 5, you store the value. And when 10 Fibonacci of 10 asks for the value of 5, you can give the Fibonacci of 5 when needed. So yeah. Uh, there are two ways of solving dynamic programming. First is top-down approach, and second is bottoms-up approach. So, from where I learned yesterday, he told that top-down approach is what is uh, to be practiced as a beginner. Okay, so yeah. So let's start with most. So what does dynamic programming do at core? It takes a recursion tree and then converts it into a DAG, directional acyclic graph. DAG, DAG. Okay. So, like if we have something like this, like Fibonacci of 10, it will have Fibonacci of 9, Fibonacci of 8, Fibonacci of 8, Fibonacci of 7, Fibonacci of 7, Fibonacci of 6, and so on, right? Till 1 and 0, of course. But what happens when we use dynamic programming, right? First, 10 is called, then 9 is called, 8 is called. Okay, we will write 8 over here. 8 is called, 7 is called, 6 is called, 5 is called, 4 is called, 3 is called, 2 is called, 1 is called, and 0 is called. Okay, let's go like from up to down. 10 to 9 and 8. Like first 9 will be for 10, 9 will be calculated first, right? For 9, 8 will be calculated first. 7 will be calculated first. 6, 5, 4, 3, 2, and as you come towards 1, you get 1, and from here you get 0. From again you get 1 and 1 over here. So when you get 1 over here, 3 will go for next value, that is 1. 1 plus 1, 2. 4 will go for the next value, which will give it 3. 5 will go for the next value, which will give us 5. 6 will go for the next value, which will give it 8. 7 will go for the next value, which will give it 13. 8 will go for the next value, which will give it 21. And 9 will go for the next value, which will give it 43. And then 10 will go for the next value, which will give us 64. Did you see, like, only this much amount of states were calculated? Like, only these were the vertices which were made during this dynamic programming, like when we use this dynamic programming approach. So yeah, what does dynamic programming do is that it converts the recursion tree to a directed acyclic graph. We will understand it by this question. It is a standard question, but there is just a twist in it. I'll add a page. It's a page. Suppose you have uh, weights and a profit according to it, like weight 1, weight 2, profit 2, weight 3, profit 3. And you will be given a bag over here, and you can fix, you can put the, uh, you can put items into it. You can have maximum W weight and maximum K items. So yeah, what all will be given to you then? What all will be given to you? First things which will be given to you is size of, like, how many items you can have. First things. Second thing will be given to you was, will be size of, like, will be weights of n items. N items will be given. Then weight 1, weight 2, till weight n will be given. Then uh, uh like, what associated profit. What associated profit will you have with each of the night, each of the item you will be given that. So yeah, after you get all of it, then you will have to calculate how much maximum, like, how many, which items you should take from this so that your profit is max. Weight, total weight is less than W, less than equal to W, and total items is less than equal to K, right? So, what sir told us to think is, like, you will have to first ask question, like, uh, what do we actually have to do? Like, we will go to this item, we will see that, can we take this item, or should not we take this item? We will think, right? Should I take it or should I leave it? After, if we go to each item, should I take it and should I leave it? We will have total how many states, like, how many total ways can be there that you can have items in your bag. You will have 2 to the power n ways, right? You will have 2 to the power n ways. So, uh, yes, 2 to the power n options. So, to solve any question, uh, to solve any question, you will have to go through the framework. What is the framework? First, what form the question is, right? Have I written it over here? Have I not? Mm, fine, no problem. Like, what exactly do you have to find? Do you want a subset? Do you want a subsequence? Or do you want a subarray? Right? What exactly you want, you should uh, like, understand. So here we can have a subset. Okay, we will have a subset over here. Oof. Like, we can take any items, right? We will have a subset, and you will probably know that, uh, if n set has n items, then the power set of that set has 2 to the power n items. The power set is set of all the possible subsets of set. Okay, so yeah, now you have understood, like, this is form 1. Okay, I'm just telling to take or not take and to form a subset is a type 1, a form 1 type of problem, right? Now, how do we design the recurrence of it? Okay, how do we design the recurrence for it? Like, if you're on a particular ayat element, and now you have to choose, like, whether should I take this ayat element or whether should I not take this ayat element, right? Whether should I take the ayat element, and should I not take the ayat element? So we'll have I. Now, uh, what should be the remaining, like, states? Mm, anything which tells you about the transition, will be present over here. Okay. Now, how should I explain it? Like, I'll go through my notes only. Mm, subset. Now I know that I have to take this, but okay. First item will be decision item. Like, you have to take decision on it. And second will be restrictions. Like, how many restrictions do you have? Here you have two restrictions. What? Weight 1, weight and K. So, uh, how can you put restrictions? Like, how can you think it by first principles? Mm, like total weight. Yeah. You can have total weight over here. Like, what is the total weight till now? And total items. Fine. This can represent. So we will represent it by small k and small w. So yeah. And what will this dp return? What will this dp return then? It returns what is asked in the question, max profit. Fine. So to move towards like decision tree, we'll have like this. Now we will have design transition. I don't know. I am not very proficient in teaching right now. I don't know. DP, high, W, K. Now we can have two options. First is that we take the ith item, and second is we do not take the ith item. So either or not, we will have to move to the next item. So I plus 1. What if we taken the ith item? W plus weight of I and K plus 1. If we take the item, and if we not take the item, I plus 1, W and K. It will return something and it will also return something. So we will have to take max of both, right? That's what I have understood from it. Now, the fourth and last thing you will have to check in it, that what is the time complexity of it. And how will you check the time complexity is first you will have number of states. Then you will have 1 plus number of uh, states, 1 plus number of average transitions. States and number of average transitions. What is the number of transitions in it? Like it is the first transition, second transition. So average transitions would be 2. And what will be the number of states? Number of states will be nothing but these values, N, W, and K. So N into W into K into 1 plus 2, 3. So we will have O of uh, like NKW. And if we were given the constraints like N is less than 100, K is less than 100, and W is less than 100, we know in 1 second 10 to the power 8 iterations can be performed. 1 second 10 to the power 8 iterations can be performed. So to calculate this 10 to the power 6 iterations, so yeah, it will be less than it. So we can use this approach, right? And what was the last thing? Hmm. It's basically a DAG. Okay, so now code a question, like now we will have to code the solution, but I think it's very easy. Yeah, that's it for now.